you have to keep it towards backfill side, since so the soil which retains above this base slab, so this also acts as a part of a retaining wall with different materials. So this also resists the lateral pressure. So that's why this slab should be as maximum as possible towards the backfill side. Okay? And coming to the vertical slab, which we are calling stem. So generally, this side is vertical. Right? Backfill side generally we provide vertical, but other side, so one vertical 2.02. This is the minimum generally. Is advisable to provide this, right? And top width is more or less same. So here top width in both the cases same, bottom width is also same, right? And slope is also same, right? And only the variation here, this minimum thickness is 0.1 H here, right? So here rest, when you see this is 0.1 to 0.17 H in the gravity. So rest you will provide inclination something like that. This inclination may be different, right? So it will be more than this 0.02, right? So this is how you have to proportion it, right? So initially you can calculate the head. Let's say H is known, so you can calculate the earth pressure. To resist that head pressure, first of all you should assume the dimensions of retaining wall. Otherwise, so you can't check the stability. If you want to check this stability, that is factor of safety against sliding, right? Factor of safety against overturning, factor of safety against bearing capacity failure, right? And no tension to occur. So if you want to check all these things, you should have dimensions. So for that, based on the height, right? So now if you see, all the dimensions are more or less related to the height of the backfill. How much height of the retention is there, or what is the difference in height of the ground levels? This is the lower ground level, right? And this is upper ground level, in other words. So the difference in height, based on this only we'll try to find. But here H is up to the bottom, right? Even in both the cases, we are considering up to the bottom of the retaining wall, right? But so of course this H depends again on actual height. This is the actual difference in height, isn't it? So similarly here also you will have downstream side depth of retaining wall is D, right? So here also you need to see this is the actual difference in height, whereas H is, in addition to this, you will have depth of 40. That means H is equals to height actual plus D. D is depth of footing, DF, let us say. DF is depth of footing, or D, which we are calling, right? Is it clear? So you should have a slight idea about the how we will proportion. The idea is, or in other words, the purpose of discussing this proportioning. This is called proportioning. So proportioning of retaining walls. The main idea is to see that this factor of safeties are slightly above the permissible limits. They should, let's say, if this is exactly required, whereas this is 3 times or more, 2 times more than actually required. Let us see. So, if this factor of safety, what should be the factor of safety in sliding? How much it should be? Anyone?
1.4 to 1.7.
So it should be more than 1.5, right? It should be more than 2. It should be more than 2.5 to 3, right? So this is generally we are discussing in the retaining walls, isn't it? Suppose if you get this is 1.5, and whereas here instead of 2 you are getting, let us say, something different. Instead of 2 you got, let's say, 4.5, whereas here you got 1.6. That means, so here if you are getting very high value, or let us say here you may get, let's say, 2.1, and here it may be, let us say, 2.9, something like that. So if it is abnormal, so to avoid these things, so this proportioning is required, right? And even after proportioning, let's say when you calculate factor of safety, sliding, overturning, and these bearing capacity failures, let us say, for example. So once after determining, right, you can see the values, right? If one of the factor of safety is very high than the permissible limits, so just try to minimize some components that I think we have discussed, right? And try to bring down the factor of safety. So all these factor of safety should be slightly above these limits. Then you can say your design is very economical, right? That is what you have to understand, right? Is it clear?
Yes, sir.
Okay. And the next topic is, actually I forgot just now when I opened the textbook, I'm getting the idea. I thought I finished all these things. Next is the drainage material, construction joints, right? Or LRS, I'll make use of the same figure, let's see. So dimensions are same, just I will see. Right? Now, so there are different types of joints, right? So in that we can say construction joints, next is contraction joints, expansion joints. So these are the three different types of joint generally we may have to provide while constructing a retaining wall. Retaining walls may be, let's say, 100 meters length, or let's say sometimes even more than that, right? So and height may be varying so much. You can't construct the entire retaining wall in a single day. Let us say you are going for a RCC type of retaining wall. Is it possible to construct the entire retaining wall in a single day? Let's say if it is a small residential building, you can lay a slab in a single day, but so it's not possible. That's why we will construct these retaining walls in stages. So here you may need to provide first construction joints. Let us see. Construction joint general we will try to provide. Let's say you have constructed this base slab, right? And you will leave a key type, something like this. So something like this. You can provide an even number at different places, and so that you will have a connection between this base slab and the next day where you are going to lay this. Let's say, so again, and next day you are laying up to this. So you can provide a key, something like this, right? You can also provide even 2, 3. It's all it depends on the dimension of this one, right? So this like this. Next day you will start constructing like this, right? So this is called a construction joint, right? So this generally we will call it as key. So even for the footings, let's say generally you will lay the footings one day, and afterwards you will start constructing the column, right? So just before constructing the column portion, let's say you are laying the footing, we will place some wooden plank so that you can provide a key, so that there will be a good joint between the footing and the even column, even for residential building also. This is also something like those who have worked in site, they might have seen this, right? This is one way of construction joint. These are called keys, right? And instead of providing keys, you can also provide, shall I erase this? you can also provide a rough surface, right? Let us say you are constructing this today, right? So here you will make smooth, and here this construction area you will make it rough, something like this. And next day you will construct. Let us say you will construct up to this, right? This surface you will make it rough so that you can construct in a lifts, something like this, right? So this is, in other words, a rough surface. You can provide a rough surface, or you can provide a key shape, right? These two types, we will call it as a construction joints, right? And we will also provide a contraction joint, right? Let's say if you see from the top, right? Let's say if this is in the plan, so this is, in other words, contraction joint. Right? So we'll provide a contraction joint, something that at a regular intervals. Let's say if length is there, right? So you are providing 300 meters of length of a retaining wall. So you will not construct 300 meters length in a single day. So you may have to provide a construction joint, something like this. Right? And similarly, you will also provide an expansion joint. Right? So here, let's say when you are constructing a very lengthy retaining wall at every 30 meters or let's say 100 meters, generally you will provide a joint. So this is called expansion joint, right? So very thin, maybe a centimeter or 2 centimeters, something like that. You will just provide so that in temperatures during summer, there will be expansion in these materials. So if you don't provide, you will find there will be the expansion, and finally this material will get crushed, right? So to avoid that, we will try to provide expansion joints at regular intervals, right? And here, these contracted joints will provide a groove of here. This is width will be around. This width will be around 6 to 8 mm, and this depth will be 12 to 16 mm. So these are the construction. The contraction joints are the vertical joints. Right? So placed in the face of the wall, right? So that allow the concrete to shrink without noticeable harm. So the dimensions may be something like that. And expansions joints are provided to take into account